My name is Kainton the Genius, and today I'm going to explain sufficient statistics. Sufficient statistics is actually what I'm going to explain. So this was a bit dicey when I was trying to read it. It was a bit tough to understand, but let me just explain it in a simple way, just like I've explained in my website right here. So you can actually read it up, and I'm actually going to explain what I have here. Now, sufficient statistic is a statistic that contains the summary of all information about the parameter being estimated. So let's illustrate. So let's say we have a population. I normally use a population to illustrate. And then we have a parameter that we want to estimate. Let's say that parameter is this. And that is the mean of this population. And to get it, we take a sample, put some items in this place, and we have a sample mean. Of course, you know you need to take several samples, and then you have a sampling distribution, x2, x1, x3, and so on. So you take several samples and have a sampling distribution. In that case, the mean of these samples will give you, will actually, the mean of x1 plus x2 plus x3 plus xn over n will give you, will tend to give us this. Okay, now we are saying that sufficient statistic is a statistic that covers what information is available in the parameter, right? In the first place, for it to be sufficient, first, it should be unbiased. It should be unbiased. That is the first. That is the first. The first requirement for consistency. Can we say an unbiased statistic is sufficient if it contains all the information in the parameter? So let's say we have all of this. Once we have this, now the main population is no longer important. Sorry for this. So now, let's now see if we calculate, let's say, take a number of items to be 4. We take 4 items, n is equal to 4. And we take 2, 3, 4, 7. This is our sample, okay? And then we calculate the mean is going to give us is equal to 4. And if this 4 is actually the parameter value, then it means that if we also take another value, 1, 4, 5, 6, it should also give us equal to 4. So what it means is our sampling estimation, our estimator should give us the value or the information contained in the parameter. And that is one, it has to be unbiased. And remember we discussed unbiasedness. An unbiased statistic, maybe we'll just review it. A sample is considered to be unbiased when the mean of the sampling distribution of the statistics equals the parameter being estimated, right? So what we are saying is that the mean of all these means should give us exactly what is here. So that is why we say it has to be first to be unbiased. However, if along the line we have 1, 4, 1, 2, and in this case, what we now have is equal to 1 plus 4 plus 8 over 2, which is 8. And now we will have a problem. So in this case, we'll be questioning this statistic being sufficient, right? So this is where we have some issues. So if it's sufficient, it should give us the value of the parameter. No matter how, whatever combination we have should always yield the value or close to the value of the parameter. So try to read it up in my website, KentonGenius.com. You'll see it in the description box below this video. And I'd like to thank you for viewing. We see you in the next lesson, where we are going to now discuss Craméral inequality, and then we differentiate between point estimate and interval estimates.